Hello everyone, welcome back to the course on Learn to Read Architectural and Structural Drawings with ETABS. In this lecture, we'll try to see how that sunken portion of a slab looks practically on the side. We did not see that, we just saw how it looks on the paper, on a drawing sheet. But we'll try to see a video and also we'll try to see how it looks practically. And after that, we'll try to see the staircase reinforcement details and how the staircase is practically done on the practically given on the side. So we'll quickly get into that. Yeah. So if you can remember, yeah, before that, let me show this image. What we saw here, we saw that there is a sunk portion. This was my toilet area and it was sunk by 300 mm. And I told you that all the slabs will remain in this position, whereas the sunken slab will be taken to this level. This distance what we have, that will be 300 mm. So we'll try to see that practically how it looks. So if you observe it carefully, you can see this, right? All these are the slab, but this was the portion where the toilet was coming, and you can see this slab, right? So you have this slab up to this, but it hasn't been sunk. So this slab, what you can see, it's all, there's a slab here, but that has been sunk by 300 mm. That means this, yeah, yeah, this distance what you can see here, right, from here to the top to this distance is actually 300 mm. So your toilet floor slab is here, the toilet floor slab is here, and it has been sunk by 300 mm from here. So we will take the plumbing lines. You can see the sleeves given here. So these are for the plumbing. For the plumbing it has been given. Once the plumbing line goes in, then what we do is we try to fill this particular area with sand, or let us say you can fill that with brick beds. Brick beds, they are the broken bricks. Brick beds, they are the broken bricks. With that we are going to fill it, and we are going to, then match this with this level. But that will be done only when the plumbing lines and all are taken up. Otherwise, this is how it looks practically once we do the casting, right? Yeah, then we'll try to see a video of how it looks practically. It's the same thing, but I want to show you practical point of view. So this is how it's going to look. So they are doing a curing here, since the slab has already been casted. We have to do the curing. That is why you can see the curing here. Yeah, allow the water to stay here. So this distance, what you can see, no, this distance will be 300 mm. This is the level of a slab, and this is a beam which you already seen. This beam was there. That is why you can see a beam here, right? Yeah. So this was all about the sunken slab and how it has to be understood. Now we'll try to understand how the staircase layout looks, and we'll try to understand them. So coming to the staircase section, so this is what my staircase is. This is my staircase. Yeah, before that we can try to see this. You have a staircase here, right? So this is a staircase what I have. So I'm just looking into the plan, but I don't see the elevation, and I don't see a structural staircase reinforcement. For that I need to look in this way. So this is how it is given. This is a staircase what I have. So as I mentioned, you're taking a up from here. That is why the up was written here. You can see the up written here, right? The up is, it's not, you're not taking a staircase from here. You're taking a staircase from here, and this is how you go. So as I told you that according to the vastu, it has to be a clockwise. Now if you are now from this diagram, it will be easy for you to understand what that clockwise means. You can see the number one written here. That means you're taking your first step from here. 1, 2, 3, 4th, 5th, 6th, 7th, 8th, 9 steps you have. This is a landing slab. You will go and land here. From this you walk here, and from here you take the second flight. You're getting my point. From here to here it is a first flight, up to 10, what is written here, no, this is my first flight, right? And once you land here, you're going to take the next flight. So you are landing here. From here you're taking the second flight. That is, you come here, you're taking this stair. This is my first flight. You land here, and from here the another flight goes. This is how it is. This is how it is. This is my first flight, and this is my second flight. This is my, I'm seeing it from a plan. From the plan it looks like this, but if you're looking at from the elevation point of view, So this is how you are taking the first step. I mean the first flight. That is why it is written here, first flight. And this is your second flight. That is why you can see a second flight here. So again, the one is written here. That means you're taking a stair in this way, and you're going to the second. You're going to that floor in this way. That means you're taking a clockwise movement, isn't it? You're taking a clockwise movement, right? Now we'll try to understand them. What is thread? What is riser? And what is landing width? The thread means that we'll try to see it through an image. This what you this distance what you can see here, right? This distance what you can see, 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 the place where you keep your foot, that is called the place where you keep your feet. This distance, it's the same thing. This distance what you can see, that is called as thread. That is called as thread. And it is mentioned the thread has to be how much? The thread should be, the thread is 350 mm. So this thread what you are providing here, the thread what you are providing here, it has to be, it has to be 300 mm. The thread what we are providing, this, that means 1 feet 300 mm, so it has to be 300 mm. Similarly, what is written here? Riser. So this is rise, this is a we call it as rise, but it is technically it is a riser. So that riser height is 150 mm. So what is trying to tell is, this height what you can see here, this height what you can see, right? This height what you can see, this height is called as rise. It is a rise. It is rise actually, but we call it as riser. Once you put the once you do the plastering, or once you put the marble and all, we call this as riser. That height should be 150 mm. So usually we keep it as 150 mm. And usually this thread what you're able to see here, right? That usually is kept as 300 mm, or sometimes 250 mm, or 300 mm. It depends. So yeah, we are keeping it as 300 mm. This is 300. And this riser what you can see here, this riser what you can see, that is 150. Generally that is what we try to keep, 150 mm. Because if you're keeping too much of riser, then it is difficult for you to take up the stairs. That is why we try to decrease the rise, and we try to increase the what is that thread, so that it is easy for us to access that staircase, right? It is easy for us to take that staircase. Otherwise, if you are keeping more rise, then it is very difficult. Right, you have to put in lot of energy to take up the stairs. That is the reason we don't try to increase it more than 150. Sometimes engineers may try to give 150 or 170, 175, 175, but not beyond that. Usually 150 is what we try to keep, right? Yeah. And this is the first flight. If I want to add one more word here, yeah. So yeah, let me discard it. Yeah. So the one what you can see here, right? This is my first flight. This is my first flight. And this what is going here, right? This is a second flight. That has been shown in the cross section. We'll try to see that this is my first flight, and this is my second flight, right? Yeah. And these are the steps, and these are the rises, and these are the thread. We'll try to see that how to understand them. So going back to this, yeah. So this is my first flight now. So it is a cross section given here. So this is how I'm going to take up my stair. My first step, second, third, fourth, fifth, sixth, seventh step, eighth, ninth, and 10th. This is my landing level. So what is mentioned here, try to observe. It is written wherever there is a dot here. I'll try to zoom in. Yeah. This dot what you can see here, there's a dot here, there's a dot here, there's a dot here. So wherever there is a dot, it is a distribution bar, and that you have to provide 8 mm at 150 center to center spacing. Similarly, the one which the bar which goes in this way, the straight bar what you can see here, right? The straight bar what you can see here, it has been mentioned that you have to provide a 12 bar at 100 center to center spacing. That will be your main bar, whereas this dot, the dot and dot will be your distribution bar, which is 8 at 150 center to center spacing. Similarly, if you come to the top level, I mean here, it's a mid landing level. Again here, the main reinforcement what you can see, it is a 12 diameter bar at 100 center to center spacing. And the distribution bar, yeah, both the bars here also, this is also main bar, even this is also main bar here. that also you have to provide it 12 diameter at 100 mm center to center spacing, and this is also 12 mm bar at 100 mm center to center spacing. This is what you need to provide here. I feel he is showing, yeah, yeah, 12 mm at 100 mm center to center spacing, 12 mm at 100 mm center to center spacing. Now, coming to this, what is this? MB is written beam MB. MB stand for mid landing beam. MB stand for mid landing beam, right? So, since it is a beam, we'll try to see how that beams look. You can see a beam here, right? Let me show that. Yeah, see, this is my first flight and this is my second flight. You can see a beam which is crossing here. So the beam what you can see here, it is called as a mid landing beam. The beam what I can see here, this beam what I can see here, it is a mid landing beam. MB is mid landing beam, or sometimes we can write it as MLB. MLB stand for mid landing beam. So the what is the cross section of this beam and what is the reinforcement that you need to provide in this MLB, that is written in the staircase detail itself. We'll try to see that. Yeah. So what is written here? The details of beam at mid landing beam. So it's written here details of landing beam for staircase. You have to provide a 12 diameter 4 bar at the top, and in the bottom you have to provide a 16 diameter 2 bar that will go continuously, and again you have to provide a 12 diameter 2 bar at the center. So bottom you have to provide 4 bars, and top also you have to provide 4 bar. Whereas this 12 diameter 4 bar you have to provide in this way, and bottom you have to provide 16 diameter 2 bar. The outer are the 16 diameter 2 bar. This bar and this bar is the 16 diameter 2 bar, and the inner bar what you can see here, they are the 12 diameter 2 bar. So this is how it has to be understood, and this is that length up to where this main bar has to go. This length has already been given by the structural consultant. This length where you have to take it is 1400 mm, and same is from here as well, right? So since here more negative bending moment will happen, we are giving more steel here. Similarly here, yeah, more negative bending moment will happen, so that is why we are giving the top steel here. But whereas in the center portion you have only sagging moment, that is reason we are giving only the bottom reinforcement and you don't have any top reinforcement here. What I'm trying to convey is, this is how the behavior of a staircase is going to happen. Again you have a negative here, negative bending moment, positive bending moment here. That is why you can see, forget about this, I have to take this up to here. So here in the center you can see only the bottom steel, whereas near the support and near the support you can see the bottom steel as well as the top steel, right? So that is the reason how this is how the reinforcement is worked out in the staircase. Similarly, if you're going to the next flight, again it's the same thing. Again, this length what you have to provide, this length what you have to provide is 1400 mm. This bar up to where you have to do the curtailment, from here it is 1400. Again, this is your 10th, 11th, 12th, 13, 14, 15, 16, 17, 18, 19, 20. These are my steps which goes to the first floor, right? And again you have to make use of a distribution bar of 8 mm at 150 center to center spacing. And this main bar what you're providing, it has to be made up of 12 mm bar at 100 mm center to center spacing. So this is how the reinforcement details is given. And this is my mid landing beam. MB stand for mid landing beam, and this is my landing level. This is a place where I do the landing. This is a place where I do the landing. So this is how it is, right? So main bars are of 12 mm at 100 mm center to center spacing, and distributions are 8 mm at 150 center to center spacing. Whereas even here also it is the same thing. That this is how we have to provide. So this is my first flight, and this is my second flight. So we'll try to see a video practically how this staircase is done, so that we get an idea. So this is exactly that staircase which we saw now. Okay, this is the second flight. What they're doing? All these are the slab reinforcement. All these are the slab reinforcement. From the slab itself, this staircase shuttering will be put up. So you can see this. These are my main reinforcement, which are 12 mm bar at 100 mm center to center spacing. This bar and this horizontal bar. What you can see here, they are my distribution bar. These are my the horizontal bar. What you can see here, they are my distribution bar, which should be made up of 8 mm at what was given there. Yeah, what was that? 8 mm distribution bar where 8 mm at 150 center to center spacing, right? Yeah. So this is how it is going to look. So this bar they are going to do a crank and bring it here. These are my top bar. Since your negative bending moment is more, you are going to put more reinforcement here. Similarly, even in this support also you are going to put more reinforcement. Whereas in the center portion you have only the bottom reinforcement, because in the center what will happen? Sagging moment is more. There is no negative bending moment. But whereas near the support and here we have more negative bending moment. Now he is going to mark the distribution bar so that it will be easy for him to tie those distribution bar. You can already see a distribution bar been put up here. These are your distribution bar. These are my main bars, right? So he's trying to crank the bar that has to be bent, right? So that is why he's trying to crank it with the help of the lever. We call that as lever. The one what is holding in the hand, that is called as lever. With the help of lever, he's trying to bend it. So the horizontal bar, what you can see here, right? All these are my distribution bar, which have been placed at 150 center to center spacing, and they are made up of 8 mm. Yeah, we'll try to go move ahead. So once that is done, he's trying to mark the distance of 150 center to center spacing, 150 center to center spacing, and 150 center to center spacing, so that he can keep his bar. All these are 150, 150, 150 center to center spacing. Once that marking is done, he is going to place that distribution bar over that and tie it with the help of a binding wire. All this spacing, what you can see, it's a 150, 150, 150. And this is a distribution bar. What he'll tie? He'll tie one in the bottom, one at the top, one in the bottom, and one at the top. You can see that, right? Yeah. This is my main bar, and these are my distribution bar. These are the distribution bar. One bar at the top, one bar at the bottom. One bar again is going to tie it at the top, one bar in the bottom. This is how they tried. This is how they try to do it. These are called as binding wire. With the help of a binding wire, they try to bind it, and this is how the bars are tied. Right? I hope you have understood up to here. So if you want to understand this in a more better way, there's a course of mine where I've explained you everything regarding how this shuttering is to be put up, how this bar has to be put up. Since this is a class of all about understanding the architectural and structural drawings, so I don't want to add those things even in this, how to do the marking of the shuttering and all. But if you're interested, you can watch it from there. Yeah, so that is how it is. The reinforcement what we saw is this is the reinforcement what he was trying to do that. So this bar what we saw now, this what the cranking he did now, the what cranking he bent the bar, right? He was trying to bend this bar. You can see this top, this bar he tried to bend it, this bar he tried to bend it, and this was a distribution bar what he was placing. You can see one at the top, one bottom, one dot, one top, one bottom, one top, one bottom. This is what he was trying to do there, right? Yeah, other than that, rest all things are understood. Again, it's the same thing. We have seen how a mid landing beam looks. This is a reinforcement that is to be given in a mid landing beam. And one thing what I want to add is the landing width what we have, that is 1460. This landing width what we had, this is a landing width, this landing from here to here, this is my landing width, this is 1460. Yeah, this is 1460 is my landing width, right? Yeah. uh, yeah, I hope it is understood up to here. We'll see you back in the next lecture. Thank you.